Imagine you're doing a routine spacewalk outside the International Space Station. You reach for a handhold, you miss, and now you're drifting. Not fast, not dramatic, just slowly separating from the only thing keeping you alive. 250 miles above Earth. Here's the thing though, what happens next is nothing like any movie you've ever seen. The physics are weirder, the ending is more terrifying, and honestly, the final act is one of the most beautiful things that could ever happen to a human being. Today, we're going to walk through exactly what happens if an astronaut floats away from the space station, and every single point on this list is going to break something you thought you knew. Let's start with the part that breaks everyone's brain first. Your gut says, push off the station, drift away in a straight line, disappear into the void forever. Clean, simple, terrifying. Except that's completely wrong. Because you and the station are both hurtling around Earth at 17,500 miles per hour, and that changes everything. The moment you separate, you're not just floating, you're orbiting. And orbits follow rules that feel absolutely insane until you understand them. Here's the wild part. If you push off perfectly sideways, perpendicular to the station, orbital mechanics will actually curve your path. You'll arc away, loop around, and roughly 90 minutes later, one full orbit of Earth, you will physically boomerang back toward the station. You don't drift into deep space, you swing back like a human tetherball. Scientists call this the Howiversity equations. You can call it the most counterintuitive thing in all of physics. Push forward, you raise your orbit, slow down relative to the station, and fall behind it. Push backward, you lower your orbit, speed up, and drift ahead. There is literally no direction you can push that sends you sailing off into the galaxy. Space isn't a swimming pool, it's a racetrack, and you're already on it. But here's where it gets scary. Because that boomerang effect, it only saves you if you do nothing. The moment you panic and try to correct yourself, you change your trajectory. And now, the rules get even more complicated. Which brings us to the jetpack. Every astronaut doing a spacewalk wears something called SAFER, Simplified Aid for EVA Rescue. It's a small jetpack strapped to their back, and it sounds like the solution to everything. It is not. SAFER contains about 3 pounds of nitrogen gas. That gives you a maximum speed change of roughly 10 feet per second. That's it. We're not talking Iron Man. We're talking a very expensive fire extinguisher. You get one shot, one careful, calm, mathematically precise burn to slow yourself down, aim at the station, and drift back. If you panic and hold that joystick down, you will burn through your entire gas supply in seconds, and then you're spinning, helplessly, with an empty tank and absolutely no way to correct it. The movies always show the jetpack as this elegant, graceful rescue tool. In reality, it's a single-use lifeline that demands you stay completely calm in the most terrifying situation a human being has ever faced. Most people in that moment would panic, and panicking means the jetpack is gone in under a minute. So the jetpack is empty? Fine. Why can't the crew just fly the space station over and grab you? This is the part that really gets people. The International Space Station is the size of a football field. It weighs 900,000 pounds. It takes days of careful planning, precise calculations, and coordination with mission control just to slightly adjust its altitude to dodge a piece of space debris. There is no quick turn. There is no rescue swoop. There is no spare spacecraft fueled up and ready to launch in time. Your crewmates, your friends, will press their faces against the cupola window, that beautiful glass dome with the best view of Earth in human history, and they will watch you drift away, completely unable to do a single thing to help you. That's not the vacuum of space that gets you. That's not the cold. It's the helplessness. The most advanced machine ever built by human hands, and it cannot turn around fast enough to save one person. That image, a crew watching through glass, hands on the window, that's the moment that should haunt you. But here's what actually ends the story, and it's not what you think. Everyone assumes the vacuum of space kills you instantly. You explode, or freeze, or boil. None of that is true. The spacesuit is a fully self-contained mini-spaceship. It protects you completely. You're actually fine for hours. The thing that kills you is your own breath. Your suit carries 6 to 8 hours of oxygen, but you won't even come close to running out of oxygen. Your real enemy is carbon dioxide. Every breath you exhale fills your helmet with CO2, and the suit has scrubbers, lithium hydroxide canisters that absorb it. But those scrubbers have a hard limit. Once they're maxed out, CO2 levels inside your helmet start climbing, and CO2 poisoning doesn't feel like suffocation. It feels like being drunk. Your head pounds, your thoughts get fuzzy and slow. You feel strangely warm and calm, and then you get very, very sleepy. The medical term is hypercapnia. The experience is basically being gently sedated. You don't gasp, you don't struggle. You just close your eyes inside the most expensive sleeping bag ever made, with the entire planet Earth filling your visor. It's dark, it's quiet, it's almost peaceful. And then comes the finale. If you've been watching this far, this is the part you came for. Because what happens to your body after that? Do you become some eerie mummy drifting past Jupiter a million years from now? No. The ISS orbits in what's called low Earth orbit. And low Earth orbit is not a perfect vacuum. There are trace particles of atmosphere up there, constantly creating a tiny but real drag on anything orbiting. The ISS fights this drag constantly with thruster burns to maintain its altitude. Without those burns, orbits decay. Slowly, but inevitably. Without you firing any thrusters, without anyone boosting your orbit, that faint atmospheric drag will grab your suit. Over the course of a few months to a couple of years, your orbit will spiral inward, lower and lower, closer and closer to Earth, and then gravity takes over. You will hit Earth's atmosphere at Mach 25 times the speed of sound. The spacesuit has no heat shield. The friction will be instant and total. And for a few brilliant seconds, you will become a streak of glowing plasma blazing across the night sky. A shooting star. Someone on the ground will look up, make a wish, and have no idea what they're actually seeing. You didn't drift into the galactic void. You came home, spectacularly, beautifully, in the most dramatic way the universe could possibly arrange. The astronaut who floated away from Earth ends their journey by lighting up the sky above it. So let's bring it all together. You don't float away in a straight line, you boomerang back in orbit. The jetpack gives you one shot, and one shot only. The space station cannot turn around to save you. Your own breath is the thing that ends it, and your final act is becoming a shooting star. Reality is so much weirder and more beautiful than any movie ever dared to show. If this broke your brain a little, drop a comment below. Tell me which point hit hardest. My guess is the shooting star gets most people, but the boomerang effect is the one that genuinely rewires how you think about space. And if you want more of this, real science that sounds completely made up, hit subscribe.